distributing. Always start at the beginning to go backwards. That way we make this connection. So, people taught FOIL. People taught FOIL. This is going to be on your notes too. Enjoy that. Ringing. Alright, so FOIL. We don't want to figure out what F stands for. I don't want to figure out what the O. That just takes too much time. All I have to do is take this guy right here and multiply it by him and him. Take this guy right here, multiply it by this one and this one. That's it. What if there was 3 terms over there? How many times would I multiply this X now? 3 times, right? There's no need to make all this. And the reason I don't teach FOIL is because if I did do one like that, let's just make one up real quick. Let's say I do that. If I tried to FOIL this, first, outside, inside, last times last. Notice what never got touched was the 2x. That's because you can't FOIL this. So why would I teach something that only works one time? What does my way do? My way says, hey, multiply this by how many things? 2. How many times by this? 2. How many by this? Is that really that hard to teach or to do? Now, combining the like terms and making sure that's a whole nother conversation, but that should be from Algebra 1. But as far as FOIL, I get rid of FOIL. I don't do that. All right? So let's talk about this one right here, and we are going to study what happens here. We're going to see, hey, where did that number come from? How did we make that number? How did we make, because there's going to be 3 terms, how do we make that front one? How did we make the middle one? And how did we make the back one? Where did they all come from? So we're going to actually take our time and look at this and see where the pattern came from. Because in a minute, I'm going to give you a trinomial, and you're going to break it down into these guys. Does everybody understand where we're going? So in order to go backwards, I first need to know how to go forwards really well. And let's see where all this stuff comes from. So this times this got me to what? X what? Squared. Be careful on that. Remember, whenever you have x times x, it's x squared, okay? This times this is going to be what? So that's where I get my 4x from. This times this is going to be 3x. This times this is going to be a 12. Now, are there any like terms that I can combine here? I can combine these guys. I cannot combine this. No. Cannot combine that with this. This is a x squared. This is just x's. They do not combine. Everybody with me on that? So I can simplify this to x squared plus 7x plus 12. How are we so far? A little head nod helps me out. All right. Now, the reason we're studying this is because we want to know, where did this come from? How did we make that? Look at it. Where did that come from? This is the only reason why FOIL is kind of good. It helps you to go backwards in just a minute. So that's the only reason I will bring up FOIL. Where did this one come from? How did we make that? Say it. The front times the front gave us this first number. Everybody okay with that? Now watch the next one. That's really easy. It's really easy. Where did this one come from? The 3 times the 4 gave us this guy right here, right? Make sense? Now, where's the booger? Because I'm going to be honest with you, like there's one that's a little bit more of a pain in the butt. Where's the one that's a little bit more of a pain in the butt? That guy. It was a combination of this times this, either added or subtracted, because sometimes it's going to change with this times this. Why did these guys add together? Because they were both plus. Do these both have to be plus every time? No. So that's what we're going to talk about in just a minute. Does everybody feel comfortable with where all 3 parts came from? All right, so now let's work on this thing. And we're going to talk, this next slide you're going to kind of just copy down, and we're going to go refer back to it. All right, so this is factoring. That should read like that. Factoring ax squared plus bx plus c. That is just, we put that big A there, we put that big B, that big C. because those are all going to be filled in with numbers. X will remain X, X will remain X there. A, B, and C will be filled in. And the reason we write that in is because I can change, based on the problem, I can change those numbers. So they are variables, but they will be numbers when you're actually given the problem. Does everybody understand what I just said? A, B, and C will be filled in with numbers. So, the first way that you always attack a factoring problem. So, while you're writing, please listen. Don't just focus on the writing. When you are, because remember, this will be posted, you can write this down later on. So if you're not great at listening and writing, you might want to just and write this later. Greatest common factor. The first thing you always try to do, if I ever say, hey, we're going to use factoring to solve this problem, the first thing you always try to do is find the greatest common factor. In just a minute, our next slide, we'll talk about how to find the greatest common factor and what that looks like. So if you don't know, we're okay. I'm going to cover it. 2 talks about these things called special cases, where you get a perfect square and you have difference of squares. Those are the 2 kinds of special cases. Again, there'll be a whole slide on those guys, and we'll talk about how you'll know when it's a special case. They each one of these things has a special thing, like a characteristic that you should be able to see and recognize. By the end of this tutorial, you should go, yep, I know that's a special case, and here's the reasons why. It's not like I just make them out and just pull them out of my butt. There's a reason why. That's what you guys need to be focused on, is why I'm doing. How did he know that was? How do you know that was a special case? How do you know that that was the greatest common factor? Number 3, we look at A. Everybody see where A is right here? That's what I'm referring to when I say look at A. If A is 1, we're going to factor a short way. You guys are going to love when A is 1. You're probably going to be like, hey, can you put like 10 of those A equals 1 on the problem, on the test? I'm going to go, no, that's not how it's going to work. I know. Remember, high levels of expectation. And then if A doesn't equal 1, that means that this right here, this A, is a number other than 1, so it'll be like a 3 here. If there was a 1 there, would there actually be any number, by the way? No, because 1x, or 1x squared, we just write it as what? X squared. Are we good to move on? Give me a, like, nope, I need a little more time, or yes, I'm good. Give you a minute. We're going to practice this probably tomorrow. Some of my classes will actually have that probably for homework, because they're going to have grade level meetings in the gym or in the auditorium. So if you are called at that time, you'll have to do that over the weekend for homework. It won't be much. It's just going to cover like 3 problems for each of the types of things that we do today, just to say, hey, I got it, or no, I need a little more help. And that's, again, for you to recognize whether you need more help or you're good to go. Make sense? All right, remember, a head nod is always great. It helps me out. All right, so here we go. That GCF thing, greatest common factor. If you remember back in the day when you were in middle school, we talked about these guys. All you have to do is write number 1 down. We're going to do number 2 and 3 together. So if you just write number 1 down, you'll be good. So greatest common factor. All right. What do you notice? By the way, how many terms are up here? See if we can remember that. How many terms are in number 1? 2 terms. How do we know what separates terms? Plus and minus signs. So how many terms do I have? 1, 2. Notice the 2x is how many terms? 1. The 2 and the x are together as 1 term. Now, do you see this term right here and this term right here? What do they have in common? They're both even numbers. That means that what goes into both of those things? 2. So what I can do is what we call factor out. I can say, you know what? You have a 2 in common. I'm going to pull that out. I'm going to take it away from both of you. I'm going to divide it out of you. So, 2. Anything else they have in common? Nope. So I go like this. Now, 2 times what would get me to this 2x? What am I missing from that first term? I'm missing just a x. So I put an x here. Now, are these 2 things equivalent? You see how I have an equal sign right here? Right now, are these two things equivalent? No. This part is equivalent to this, but what am I missing? The 8. So how do I make an 8 appear back here? I put a plus what? 4. That is called, it's called, like, how would you solve this problem? If I put this up on the board, what would you call it? You would say, hey, you distribute that, right? So what did I really do over here? I kind of undistributed. But these two things are equivalent. In math, guys, I'm going to point that out a billion times. Might be a little bit exaggeration. But I'm going to point it out almost every day that these two things are equivalent. And in math, we want things that are equivalent because if I get this that it's equivalent, I can take it out and I can put what is equivalent in its place. Because sometimes this form right here is going to do me no good. But this form helps me out a ton. And sometimes this form is going to be worthless to me. But this form right here, I can do some work with. And you see how they're interchangeable. So depending on where I need to go, I can use either form. You start seeing that in math, that you can actually start changing things out when they're equivalent. All we're doing is changing the way things look. You're going to start, math will start clicking. All right, here we go. Next one. All right, let's try this same thing. What do we see that these two things have in common? Okay? But if I need them to be, I need them to have something in common. Well, odd is good, but, okay, they have an x in common and a 3. Do you see how 3 goes into both this and that, which was why that odd, but not all numbers are odd 3 goes into, right? So that's why I needed a little bit more, but yes, they're odd. So 3, x, and x. Are you with me? So what am I going to take out of both of them? I'm going to divide out. 3x. I can say, hey, you guys have a 3x in common. I'm going to yank that out. What did I call that? If you're going forwards, we call it distributing. If we're going backwards, what did I call it? Kind of undistributed, right? So, in order for this, these two things have to be equivalent. Right now I have a 3x. Over here, what did I have? A 3x squared. So what am I missing from over here? Everybody okay with me putting that? Do you see how this times that, check, that's right there. Remember, I'm not allowed to change the value of this. I'm only allowed to change the way it looks. This, so we're good with this. This times what would get me this? What am I missing? Am I missing an x? It's okay, think about it. Am I missing an x? Because this is where we need to know, is there an x missing or no? How many x's do I have here? 1. How many do I already have over here? 1. Am I missing one then?
No.
What am I just missing? 3. Because here's how I check that. Here's how I check. 3x times x gets me what? 3x squared. Is that what I needed first? Check. 3x times 3 gets me to 9x. Is that what I was missing back here? Is that what I needed back here? Check. These two things I know are equivalent. Making sense? Like a change machine up here? That's what Mr. Rass is, by the way. I stole it from him. It will hit you at some point. Well, if you're not ready for bad puns or being silly, then go. You gotta get out of here. It's ugly. I'm bad. Oh, good. Oxygen's a big deal. I like that shirt. Alright. Try this one. This one looks ugly. It looks scary. No need to make it look ugly and scary. Take your time. How many terms are with this guy here?
3.
Does everybody know why there's 3 terms? Because I decided that. Because there's those plus signs are separating. So we got 1, 2, 3 terms. What do all 3 have to have in common in order for me to yank it out? So let's start with the easy thing first. What number, and remember, what did that G stand for? Greatest. Doesn't mean that you want to pull out just anything they have in common. It has to be the greatest thing they have in common. Here's the reason I say that. Does 2 go into all these numbers?
Yes.
Is that their greatest common thing that they have in common?
No.
And so if I pulled out a 2, that would be bad. You would end up with an X on your paper. Not good. Greatest common factor. What's the biggest number that goes into all 3 of those? 10. So we're going to start with just the 10. We're going to say, okay, got 10. Now, this is where it gets a little bit tricky, but that's why I put this one up here. How many X's does this one really have?
3.
Man, it's not 3X, it's X, X, X. Don't quote me on that. All right? So, there's 3 of those guys in a row. How many of these guys are there? 2, so I have X times X. How many are here? How many do they have in common?
2.
Does everybody see they have 2 in common? They have 2 that they both can say, hey, I've got an X, and the other guy goes, well, I got 1 too, and the other guy, I got 1. Okay, we got 1 in common. Hey, wait, I got another one. I got 1 too. I got another one. Okay, we're good. This guy goes, I got another one. The middle guy goes, I ran out of them. I got no more. Right? So we have 2 that are in common. So I can go X squared here. That's the other thing I can pull out. And last, try that on your own. See what you can get. How many Y's do they have in common? Don't have to call it out loud. Just do it real quick. It should take a minute, less than a minute, maybe 10 seconds. See what you think they should have in common for Y's. Hopefully, you put down just Y, because this has 4 of them. This only has what? 1, and this has, so when they're calling out, we got Y, I got Y, I got a Y, and we go Y. The middle guy screws us up, man. He's weak. He's only got 2 X's and 1 Y, so we can't get anything else in common. Yeah, we good? See people laughing. I don't know what, you're not used to this or what. I'm weird. Doesn't matter, teacher. But you guys are kind of making me selfish. Alright, here we go. How do I make this first term? I need to focus on this one. How many things are going to be down here, by the way? 3. There has to be 3. And we're going to talk, I need to make up one more example real quick. We'll talk about a kind of a special case that trips kids up all the time. We'll talk about that real quick. So, how do I make this? What is this guy right here missing from right here? I got a 10, right? Am I missing any numbers? Good. How many X's am I missing? So I need to put an X here. How many Y's am I missing? Does this times this get me to that? 10 times 1 is 10. X squared times X is X cubed. Y times Y cubed is Y to the 4th. Check. Guys, I loved math. You could always do that. You could check back. You could go, yes, this works. This is good. I hate English. My wife teaches it. She still doesn't make sense to me. Listen, we go. I was in class, and how do you spell pharmacy? What does the teacher say? Look it up in the dictionary. Oh, hey, genius! It's alphabetical. I'm here in the F's. Am I ever going to get to pharmacy? No. You can't sell, sorry, you can't sell a check. But they have all these made-up rules. I before you accept that, and sometimes it's okay to do that. It's free. It's called liberal arts because it's kind of flowy. That's not me. This is how it is. This is what you do. This is how you can self-check by going and making sure this times this gets me that. Now, don't get me wrong. I appreciate the arts. They're very important. I am just not a language arts kind of person. I just want you to tell me the rules, and I'll follow them. Kind of like my daughter. I'll be way over here until you stop smoking. Okay? So, did I tell you that? I told you that, right? About my daughter? Reference from yesterday if I didn't tell you the story. She used to go up to people. I would say, hey, smoking is bad, blah, blah, blah. And then she would go up to people in the supermarket and tell them about the rule that I just told her. Like, hey, you shouldn't smoke, you're going to die. Yeah, happened a couple times, not fun. So, anyways, everybody okay with first term? Next term, how do I get to that? You see how there's a plus sign here? So I'm going to put a plus sign here. Am I missing any numbers? I'm missing, right? I need 10 to pump up to 20. So how do I do that? With a 2. Am I missing any x?
No.
Am I missing any y's?
No.
So it's just a 2 in the middle. Everybody okay with that? Plus, try to finish that last one off real quick on your own. Again, just take 1 minute. See what you can do. I'm so interested to see how this plays back next period. Instant fall. All right, what number am I missing? 5. Man. How many x's am I missing?
2.
How many y's am I missing?
1.
That's called GCF. Anytime I ask you to factor, if you have a trinomial, you are going to always try to see if they have a greatest common factor. Are they all going to have greatest common factors?
No.
No. But it is the first step that you always try to do. If they have a greatest common factor, yank that joker out, and then we move on to our factoring stuff. If you skip this step, you sometimes won't be able to factor it. You're going to, Mr. Martin, it's not factorable, and I'm going to go, you missed the first step. And then when you pull out the greatest common factor, boom, now it might be factorable again. We'll get to that in just a little bit. I'll show you examples of all the stuff I'm talking about. Are we good so far? Here's the weird one.
How did you get the first one in the big parentheses?
This?
Yeah.
Okay. So remember, you're using this guy right here, and you're saying, okay, it's not going to have, all the time, it's not going to have everything it needs. How do I make this right here from here? Well, 10 times what is going to be 10?
1.
There you go. So there's a 1, right? It's imaginary. Now, I have x squared. I need 3 of them. I only have how many here? So I'm missing. By the way, who does this 3 belong to? Only the y. Does that make sense? Because a lot of kids kind of forget that. If I wanted that to be, we'll talk about that in a second. Anyways, so there's a 1, there's an imaginary 1 here for that missing x. How many y's am I missing? I needed 4. How many do I have here? How many do I have here?
Oh.
Just 1, right? How many am I missing? 3. Because there's 4 up top. Does that help out a little bit? All right, here's the weird case that can happen. So let's say we have something like that. This is just a special case, and it can happen. It can happen with these boogers down here too. But I'm going to explain it in a simpler case, but understand it can happen down here with these guys too. What do they have in common?
3.
3. What am I left with?
X plus 1.
X. Now here's the problem, right? A lot of people are going to go, well, there's the 3. You're not missing anything, so they just leave it like that. Well, what is 3 times x? Is 3x equivalent to 3x plus 3?
No.
So that's how I know I'm missing something. Because this right here is not equivalent back up to the top. If I distribute that 3 back, I'm missing something. So the way that we do that is we go 3 times what gets me to 3, and that's why he put that 1 back there, because now when I distribute it back out, 3 times x is what? Check. 3 times 1 is what? Check. Again, you don't have to go look it up in the thesaurus, or however you say those stupid words. Thesaurus. Thesaurus. Shut up. I love it. It's the second day. You cannot make fun of me yet. I haven't made fun of you. I will. All right. Next thing we're going to get to. We should be able to finish this today, and then we are good. That's good stuff. All right. Factoring. Now we're going to get down to business. Now we're going to get down to how do we do this stuff. So, we have sign rules. We have things. You are going to be a detective. You are going to, if you look at this as more of a mystery, you can only just copy the first one down. You'll have time to copy. You don't have to copy everything. If you look at this more as a mystery, if you look at this more as a problem to be solved like that, like a detective, you are going to find that mathematics is going to be much more enjoyable. So I've always made this a game for myself. And I want to know, how can I make this right here from my bubbles? Because remember, these two things are going to be equivalent. This is going to break down into something like this. Does everyone understand what I'm talking about? Okay. How did I get this? Let's talk about the back number first. How did I get this back number? What was it a combination of? How did I get that 12? What was it a combination of? Was it the middle numbers? What was it? It was the 3 times the 4. It was the last times the last. Always got me this back number. Everybody okay with that? So let's go back to this. How am I going to get this plus C? Let's say I look at this and I see, these are the 4 forms, by the way. These are the 4 different ways that we can have this. We can have a plus here, a minus and a plus and a minus, and a minus and a minus. Those are the only 4 types that we can have. So how the heck can I end up with a plus back here? What would I have to be multiplying with my last and my last? What would have to happen? Okay, I could have a positive and a positive. How do I know that they both have to be positive? Because a positive times a positive ends up what? Which I know it ends up positive down here, correct? What else could I have? What's a negative times a negative? It's a positive, right? So I know when I see this form right here, this back sign right here, when I see a plus, it tells me I know I have same signs. What does he mean by same? I know that it's either plus, or what? Do I know which one it is yet? I don't know which one. I just know that it's plus. Are you with me so far? Do you see how I'm being a detective and I'm going, oh, there's my first clue. Same signs. Now, this also tells me that I'm going to add to get to my middle number. Here's what I mean by that. When I went here, and the next ones are going to go much faster. The first one takes a little bit more time. Do you see how the middle number was 7x, yes? What happens when I have a plus and a plus together? What did I actually do when I combine them? You add those two numbers. Are you with me? What happens if I have a plus 4x, but I had a minus 3x in the other one? What would happen with those two numbers? They actually do what to each other? Subtract. They cancel out. When you have different signs, the two cancel each other out. When you have same signs, what do they actually do together? They kind of add. I know that sounds weird, but think about this. What if I had a negative 4x and a negative 3x? What does that get me to? Negative 7. I have more debt. I know that sounds weird, but I have more debt, which is no bueno. That's not good. So it's still going down. It's still kind of a stretch. But if you think of it as I'm adding more debt, that's not good. I understand that. Are you with me? Same signs. What do? You actually add the numbers. That's how we get 3 and 4 make a 7. Same signs you add. Are you guys with me on that? If you don't get that step, we're going to be in trouble in just a little bit. Are we good? All right. Don't lie to me. Now, since I know that this middle number is a positive, what do you think it tells me? This one is the one I know that I'm going to have. Why? Because when I add those two middle numbers together, what did they get me? A positive number in the middle left over. What's the only way I could have a positive is if the two numbers were positive to begin with. Are you following me? All right, let's go to this case. What does this tell me again? It's going to say the same thing. What does it tell me? The back number is positive. What's the only way I can have a positive? if they're both plus, plus, or they're both what? Minus, minus. Do I know which one of these yet? Not yet. So this tells me again right here, this tells me same signs and what? Add. That's huge. Do not forget that. That is huge. That tells me to add. We're going to use this stuff in just a little bit. Now, what does this tell me? It tells me that they're going to end up being a negative. So am I using the plus plus one? Nope. I know that my bubbles are going to have to look like this when I start factoring, which we're going to get to in just a minute. It kind of all puts it together when we start doing some examples. See how smart you are. Since you guys made fun of me, I'm going to start making fun of you. I'm not too hopeful. What do you think this says? If plus said same, what do you think? What's the only way I can end up with a negative back number? If they're different, which means right away I know that one is going to be plus in my bubble and one is going to be minus in my bubble. Automatically, boom, I can see that. Yeah, I do some more jazz hands there. What do you think, if same meant to add, what do you think different signs are going to do to each other? They're going to subtract. We'll talk about what that means in just a little bit. And this right here is going to say the bigger number is positive. Talk about that in just a minute. That means my bigger number is going to go right here. Last one. What does this tell me? Different, which means subtract. So right away, I can put plus. I can put minus. What does this tell me, though? Over here, bigger number is positive. What do you think this is going to tell me? Bigger number is going to be with the negative right here. All right, let's do some. I gave this problem yesterday on the board for some of my classes. You guys weren't here. But this is one example that I gave them yesterday. As soon as I see a problem, someone tells me to factor, first thing I look for is GCF. So I'm going to go through all the steps. This is like a factoring problem on the test. Do these guys have anything in common? No. I moved to my second one. Is this a special case? We haven't covered those? No, it's not. Third thing, look at A. What is A right here? A 1. So this is called the short way. This is the short way. What does this tell me right here? Same signs. Does everybody understand that that says same? And to what? Add. What does this tell me? Both signs are going to be. So right away, I can double bubble and put plus signs in both those. That's my, now I kind of broke it down. Now, here's the game. I need two numbers that multiply to 6, but add to 5. And those numbers that she just said go in my bubble. What goes first? X and X, 3 and 2. It doesn't matter where you put the 3 or the 2 because they're both plus signs. That's my game. Now check it out. What's X times X? X squared. What's X times 2? 2X, so I got to hold that. What's 3 times X? What's 2X plus 3X? Check, isn't that what I wanted? And 3 times 2 is? Are these two things equivalent? That means that they can be substituted or replaced with one another. They are equivalent. Anytime you see this, you could write this in its place. Anytime you see this, you could write this in its place. And we are going to do that constantly. I'm going to give you a problem, and you're going to need to factor it in order to solve it. It won't be you won't be able to do it in this form. You're going to have to turn to this. Do we kind of have an understanding of this? We're going to practice this some more. I'm going to show you some more tomorrow when we get in class. I'll probably record that, and then I'll have you doing something on your own. I'll have you practicing GCF, and I'll have you practicing when A is 1. Then next week, we're going to get into when A is not 1, and we're going to get into those special cases.